Hello everybody, I am Bhargav, Assistant Professor in EC Department of Vigyan University, and I am here to explain about the basic course, that is Signals and Systems, and this can be available for the ECE students and biomedical students also, and especially we are dealing with here Signals and Systems for bioengineers. And this is the basic lecture, that is the first lecture. Here we are going to see about the syllabus of the signals and systems and what are the books we can able to prefer for the signals and systems, and course outcomes and course objective we will see. And after that we will just introduce what is signal and what is system. Okay, then this is the syllabus for the signals and systems. Here we have 5 units. In the first unit we will deal with the classification of signals and systems. So if you see here different types of the signals and systems we will see in the first unit, that is continuous time signal, discrete time signal, and in that continuous and discrete time signal we will see different signals like unit step, periodic signal, and unit impulse signal, random signal, what is the deterministic signal, energy signal, power signal. All these signals we can able to define, and different types of the systems also you will see: linear system, time invariant system, time variant system, non-linear system, causal and non-causal systems, and stable system and unstable system. So all these signals and systems will be introduced to you in the first unit. And coming to the second unit, this is the very important unit, because here only we will see about the important topics in the signals and systems like Fourier series, Fourier transform, and Laplace transform. This Laplace transform can be applicable for the continuous time signals. Actually, this Laplace transform is applicable for the continuous time signals. The counterpart of this Laplace transform is the Z transform. Okay, the Z transform is applicable for the discrete time signals, and this Fourier series and Fourier transform can be applicable for both continuous and discrete signals also. Okay, if I apply this Fourier series for the continuous signals, that is called continuous Fourier series, and we can able to apply for the discrete signals also at that time, that is called discrete Fourier series. Similarly, the Fourier transform can be applicable for both continuous and discrete signals. So those are called CTFT, that means continuous time Fourier transform, DTFT, discrete time Fourier transform. After that DFT will be there, that is discrete Fourier transform, and fast Fourier transform FFT will also be available, and those two are not available for your syllabus. In the next subjects, successive subjects, you can able to see that one, DFT and FFT. So as I said, Fourier series and Fourier transform can be applicable for both continuous time and discrete time signals, but Laplace transform is for only continuous time signals. So if you want the counterpart to that one, that is the Z transform. Okay, so generally for the stable signals we will apply the Fourier transform, and for the unstable signals, not only for the unstable signals, for the unstable signals we can able to apply the Laplace transform, but for the unstable signals we cannot able to apply Fourier transform. So this is about the second unit. All these things we will discuss in our first 2 units. And in the third unit, here if you see, in the first unit itself we will see about the linear system and time invariant system. If any system is having these two properties, that is called linear time invariant system, that may be for the continuous time system or that may be for the discrete time system. These are the things we will discuss in our third unit. Okay, so these are shortly we can able to tell these are the LTI systems. Okay, these are the LTI systems, and one important concept in the signals and systems is the convolution property. So this convolution property can be applicable for the LTI systems only. That's why this one will be available in the LTI systems chapter only. Okay, convolution can be applicable for the LTI systems only, and this can be for the continuous time signal and for the discrete time signal also. And here we have included DTFT also. Just now I have told, in the second unit you will read about only continuous time signal. With respect to continuous time signals only, that is Fourier series is for the periodic signals, actually continuous time periodic signals. Next Fourier transform